Hey guys, welcome back to my channel. This is Varun Tahin. So in the previous sessions, we have seen the usefulness of visualization in analysis of large data. We also saw some online tools available for generic use cases and also started familiarizing ourselves with different kinds of plots. Now in this session, we will mainly cover how can we build graphs and plots using Python library matplotlib. So let's start. So in this session, we will be covering these topics, starting with the creation of basic plots using matplotlib.pyplot, and then putting axis labels and titles, then creating multiple plots or subplots using in the same figure, then changing the scales of x and y axis, and then creating some common types of plots like histogram, box plots, and scatter plots, etc. Also, at last, we will check how we can work with images. So let me give you a brief background about matplotlib and pyplot. So matplotlib is a Python library. It contains the pyplot module inside it, which is basically a collection of functions such as plot, title, show, etc. So pyplot is one of the most commonly used module for creating a wide variety of plots, such as line plots, bar plots, and histograms that we have seen earlier. Now let's see how do we install matplotlib. So we'll first go to Anaconda prompt, and then as we do for all the other libraries, we do pip3 install matplotlib. Okay, so I have already installed it. That's why it is not installing for me and saying it is already satisfied. So I'll just cross this. So this is how the installation is done. Now we'll use that. So for using it, we would need some libraries along with it also, like NumPy and Pandas. Those we have seen earlier in the previous sessions, guys. So we'll just import NumPy as np, import Pandas as pd, then import matplotlib.pyplot. Okay, so this is the module inside it as plt, I'll say. Okay, so what I do is I will try and create a 1D NumPy array. Okay, so for that I need to have x and y axis here for creating the plot. So I'll say np dot linspace 5, 100, 100. So what I'm doing is I'm taking numbers from 5 to 100. I'm taking 100 numbers from this. Those are equidistant numbers starting from 5 to 100. Okay, similarly for y-axis also I'll do the same thing. Okay, and this time let me take it as from 10 to 1000. Okay, 100 numbers equidistant from it, and I'll say plt dot plot and give x comma y. Now let's execute this. So you will see that you will get a plot with a line here. Okay, so this signifies that this is the x-axis, this is the y-axis. Starting from 0 to 100, it has taken equidistant numbers. Those are 20, 40, 60, 80 and 100. And likewise for 1000, it has taken the equidistant numbers. So you guys must have noticed here is we are taking 100 numbers, but it is showing us in a scaled manner, in a neat manner here in the plot. So if you just print x and y here, you'll come to know that you still have 100 numbers, but this plot seems to scale a bit cleaner way. So it is taking the numbers equidistant to present it in a clean manner basically. So it is auto scaling. So for y also you can check that it is taking 100 numbers. Now there is one thing to note here is that we can also work with lists. Though it converts the list to NP arrays internally, but we can still use it. Okay, so let's check one of its example. So I'll take two lists internally. So this is the x-axis. So let me take 1, 4, 6 and 8 here. And the second list for y-axis, we'll take 3, 8, 3, 5, let's say. Okay, now when I try and plot this, okay, So you will see here that each of these numbers will correspond to each of these numbers in y. Okay, so it will be like 1 comma 3, 4 comma 8, 6 comma 3 and 8 comma 5. So when you put these points into the graph and join the lines to it, you'll get this plot here. So just remember guys, in this example the coordinates 1 comma 3 corresponds to the x-axis and y-axis. So 1 is the x-axis, 3 is the y-axis, thus 1 comma 3 points to this location. Then 4 comma 8 points to this location because 4 is here in the x-axis and 8 is here. Then 6 comma 8 points to this location, and likewise 8 comma 5 points to this location. So it will give us this kind of graph. Now let's see how to put labels and the x-axis and y-axis and the chart title into this plot. So let us see now how do we specify the labels and title. So I'll say plt.plot, give x comma y here. Okay, and then here I will do plt dot x label, and currently I will be taking an example of Ohm's law. So in x axis I will take current and I'll do plt dot y label, and in y axis I will take voltage, and then I will say plt dot title is Ohm's law. Okay, so I'll give double inverted commas here. Okay, and then guys we can also specify the limits of x and y labels. So this is used when the graph is a large graph and you want a specific part only to be displayed properly so that you can analyze it properly. So we can in that case specify the x limit and y limit. So those are done by using xlim and ylim functions. So I'll show how it is done. So we'll use xlim and then we will specify the x minimum, that is starting point and the end point of x-axis, and then similarly we'll give ylim and we will specify the starting point, which is 200 comma 800 is the end point of it. Okay, and then I will say plt dot show. Okay, so this will give you the graph in limits which are specified here. So you can see, so it is starting from 20 and ending to 80 in case of x limit, and in case of y limit it is starting at 200 and ending at 800. And you can also observe now the chart is labeled with the x-axis as current and y-axis as voltage, and also the title is named as Ohm's law. So guys, this is not just the only way to draw the line. So we can even play with colors and the shape of the line. If I want to give a blue positive symbol instead of this line, I can even do that. So if I say B plus here, okay, give it in inverted commas, so you will see that this line will be changed to individual points with plus symbol, with a blue plus symbol basically. Now we can even plot multiple lines on the same plot. So for that I will make different numpy arrays. So I'll say np.linspace and keep some numbers here. Okay, and then for y do the similar thing. So I'll keep 3 comma 6 comma 10 here. Okay, and then I'll say plt dot plot and give x comma y. So for this I'll be using red line. So for red line there is r minus symbol, and then for the two other different lines I'll be using x comma y square as value for one of the line with blue plus symbol as we have used before, and then for the third line I will use x comma y cube with a green triangle. So for triangle we'll use this power symbol. Okay, so when I do plt dot show, it will draw all the three lines with x comma y being on the red line, then x comma y square being on the blue plus line, and x comma y cube being on the green triangle line. Now in some cases we would often need to create multiple plots in the same figure, so we will as well see it in the upcoming examples also. So matplotlib has the concept of figures and subplots, using which we can create the multiple subplot inside the same figure. So to create the multiple plots, you will use this plt.subplot function provided by matplotlib. So for this particular problem I have listed down some steps, so we'll do it one by one. So first we will create the x and y axis. So we'll say x equals to np dot linspace, and then I will give 1 comma 10 comma 100 some arbitrary numbers here. And for y I will simply say np dot log of x. Okay, so I'm just simply saying that take a log of whatever value are present in x, take a log of that and put it in y. Okay, so next I will just explicitly initiate a new figure. So how it is done is just have to say plt dot figure and specify one here. Okay, now what we'll do is we'll create the subplots with one row and two columns. So for that we will create the individual subplots first. Okay, so for the first subplot I will say plt dot subplot and I'll say 1 to 1. Okay, so what this signifies is this is equivalent to saying that plt dot subplot n rows, that is 1 as rows, 2 as columns, and 1 as n subplot under that. Okay, so then I will say plt dot title and I'll put the title over here so that it is easily recognizable. Let's say log of x. Okay, so this is for plt dot plot x comma y. Okay, and then we will make the other plot, which is plt dot plot say 1 to 2. Okay, and for this we will give title as y equals to log of x squared. Okay, so here I will give plt dot plot x comma y square, and then we will do plt dot show. So when we are executing this, we will be expecting a single row with two columns, because this is just 1 for n rows and 2 for the column numbers. Okay, so there is only one row and two columns, and this is the first plot or first column in the first row, and this is the second column or second plot in the first row. Okay, so let me execute it. Now you can see that it has only made one row and two columns it has segregated per plot each, and it is showing the correct labels according to the ones we have given in the titles, and also the plot is made like we have mentioned. So the first one is signifying xy, that is simply the x having linked space and y having the log of x and the second one has the x and y square. Now let's see one more example of creating multiple subplots. So let's say that we want to create 4 subplots in 2 rows and 2 columns. Okay, so for that I will use a single linspace. So I'll just use x value as np.linspace and say 1 comma 10 comma 100. Okay, and then like I've done previously, I'll say plt.figure. So this is an optional command, so you might give it or not, it will be default anyways. Okay, and then let's try and create the subplots. I'll say plt.subplot. So remember guys, we are making 4 plots, that is 2 in each row. Okay, so we'll say 2 comma 2 comma 1. Okay, then here it will be 2 comma 2 comma 2. Then this will be a figure 2. Okay, so this is again a default one. So I'll say plt.subplot 2 comma 2 comma 1, and then again 2 comma 2 comma 2. Okay, so here I'll just take plt dot title as linear. Okay, and say plt dot plot as x comma x, and here I'll say plt dot title as cubic. Okay, so here in the x-axis I will keep this as it is, but in the y-axis I will do a cube of x. Then for the third subplot I will say log. Okay, so it is different functions I'm using for x. So I'll say log of np.log of x, and at last I'll just say exponential and use x squared. Okay, then here I'll just say plt.show. So when I do this, you will observe here that all the plots will be made, separate plots will be made. Okay, sorry, this will be 2 comma 2 comma 2. So here you will observe that these all plots will be made with individual functions and shapes. So that will be all for today guys. The rest of the topics from agenda which are left will be covered in the next session. So I'm intentionally keeping this session short so that it is easier for you to practice in parts and come up with questions if you have any. So please drop them in the comment section. I'll surely answer them. Also, if you like my content, don't forget to give it a thumbs up. Also, please subscribe my channel and do hit the bell icon for more updates. Please stay safe and thank you.